In this section, we are going to talk about linear equations in two variables and linear function. A linear equation in two variables can be defined in one of the three forms. The first one is the standard form. What's special about the standard form is the variables, because it's called a linear equation in two variables, you should expect to have two variables here. And usually we use x and y. So the two variables x and y would be on the same side of the equation in a standard form. And then the other side would be just a constant. Notice that a, b, and c here are constants. The second form is the slope-intercept form. Now, in the slope-intercept form, there's a reason why they call it that. It's because just by looking at the form, you should be able to determine the slope n and the y-intercept b right away. And the third form is the point-slope form. In the point-slope form, we can see the slope m, and we will also see a point, which is the point x1, y1. Now, please note that we should be able to convert from one form to the other without changing the value of the equation. So let's talk about the slope of a line. The slope of a line measures the steepness and the direction of the line. The slope of the line passing through the point x1, y1, and x2, y2 is defined by the formula y2 minus y1 over x2 minus x1. What it really does is, in the numerator, it describes the change in the variable y, and the denominator describes the change in the variable x. Sometimes we also say rise over run, and we use rise over run when there's a graph. So let's look at an example here. Find the slope of the line passing through the given points, then graph the line. So the 2 points given to us are -3, -2, and 2, 5. So first thing you want to do is to name your points. Looking at the slope here, there are 2 points, x1, y1, and x2, y2. Please make sure that you go in the order xy, xy. The first coordinate is always the x coordinate, and the second coordinate is always the y coordinate. So now we can apply the formula. M is equal to y2 minus y1. So we're looking at 5 minus y1 is -2. And then x2 minus x1, that's 2 minus a -3. 5 minus a -2, that's the same as 5 plus 2, so that's 7. And then 2 minus a -3, that's 2 plus 3, so that should give you 5. So the slope of the line is 7 over 5. Now we are going to graph the line. Since 2 points are given, we can just plot the 2 points, connect the 2 points, and that will give you a line. So the first point is -3, -2. So -3 is here, -2 is here. So we are looking at, move this 3, -3 up just a little bit. Okay, so it's going to be this point right here. And the second point is 2, 5. So here's 2, and 5 is here. So the point 2, 5 would be this point. So once you have the 2 points, you are going to connect, and that would be the graph of the line. Now, make sure that you draw beyond the 2 points, because we need to know that the line here goes on forever to -infinity or +infinity in both x direction and y direction. Okay, so there are 4 scenarios that you might run into in terms of slope here. When the slope is positive, like what we just saw, m is equal to 7 over 5, you should expect the line to go up from left to right. When the slope is negative, you should expect the line to go down from left to right. When the slope is 0, that means the steepness of the line is 0, so it's flat. Therefore, you should expect a horizontal line. And then the fourth scenario is when the slope is undefined. In that case, you should expect a vertical line. Note that we'll get the slope to be 0 if we end up with the numerator being 0 and the denominator is a number that is not 0. So let's call it constant c. This will result in a 0. And the slope will be undefined if we end up with the numerator being a constant and the denominator is 0. We all know that we can't have 0 in the denominator. So this is where the fraction is undefined and therefore the slope would be undefined.